Hello, Chiban Acharya again. This is the video for section 7.1 homework, the properties of the normal distribution. Okay, normal distribution is the data which is bell-shaped is called normal distribution. Okay, just wanna give you a bell-shaped distribution like this, and the data here is on this line. This is called normal distribution, also called bell-shaped distribution. Question number 1. Which of the following are property of the normal density curve? Here, normal density curve. What is that? Okay, in the normal distribution, your graph looks like this. Here's the data. We call data as x here, and the curve is the bell-shaped. Okay, and this point is the maximum, and this point corresponds to the mean. Alright, mean, and that is the curve here. The curve here, where the data is in the horizontal line, is called normal density curve. The name of the curve is normal density curve. Normal density curve. Notice that this line here is the data x value here, and this curve is called normal density curve. And actually, what's the property of normal density curve? Alright, the property is this. Okay, the first one is, look at the mu here. If you draw the line on the top of the curve to the mean, you see that you have this area on the right of this line, or right of this mean, which is mu, and left of the mu are the same. Okay, and total area under the curve above this data line is 1. Therefore, this area corresponds to half area. It's the half area. If you add, total going to be 1. Therefore, the first part is A is a correct answer. Select the apply. The area under the curve to the right of mu here equals to the area under the curve to the left of mu. Both equals to half. That's the first answer, A. And C, it is symmetric about the mean mu. Symmetric in the sense that the line through the mu, this normal density curve divided into half, or in the both side area going to be equal half and half. That is called symmetric. Therefore, this is symmetric about the mu. Other is its highest point occurs at mu. Yes, see, that's the highest point here. This the highest points occurs at mu, which is the mean. Okay, and the area under the curve is 1. That's also correct. And obviously you see that half and half total to 1. Area under the curve, of course, above this data line is 1. That's the all answer, and this is not. Question number 2. Determine whether the following graph can represent the normal curve. Remember that the normal curve is same as normal density curve. Sometimes say normal density, sometimes say normal curve, is the same thing. And notice that this graph is not symmetric about the mean, right? For example, if you draw the line from the top for the peak, that's not the symmetric. You see that area on the right and left are not equal. Therefore, this graph here cannot represent a normal curve. The answer is E. No, because the graph is not symmetric about the mean. That's the right answer. You had a bunch of the options, but this is the only one correct option you choose. No, it is not symmetric about the mean. Therefore, this is not normal curve. Question number 3. Complete the sentence below. The points x and x equals whatever are inflection points on the normal curve. The inflection points are the points which are 1 standard deviation above and below the mean. For example, if this is the x here, it's a normal curve, and this is the mu, and this is the mu plus sigma, and this is the mu minus sigma. In other words, this point is 1 standard deviation above the mean, This point is 1 standard deviation below the mean, and these 2 points are called inflection points. Therefore, answer is B. The points x equals to mu minus sigma and mu plus sigma are inflection points on the normal curve. Again, this is the normal curve, okay? Or you can call normal density curve, is the same thing. All right, now question number 4. What is the name given to the normal distribution when mu equals to 0 and sigma equals to 1? Okay, there is another curve called standard normal curve. Okay, all right. If you have the line here represent the z-score, and curve is similar to normal density curve, but this is the mean here, which is 0. But notice that this mean has a z-score 0. Okay, and you have a 1 here and 2 here, so it's -1 here, -2 here, and this curve here is called standard normal curve. Okay, remember that this is called normal curve or normal density curve because this line represents the data points here, x. But this questions, and this line represents the z-score. You see, z-score. Therefore, as long as you have a z-score is on a horizontal line, the curve, the normal curve, is called normal density curve, or I should say standard normal curve. Okay, standard normal curve. The answer is standard normal here. Again, just the name of the curve is called standard normal curve. Question number 5. What is the mean and the standard deviation? What is the mean of the standard normal distribution? What's the standard deviation of standard normal distribution? And you see that this is called standard normal distribution because the standard normal curve, the mean going to be 0, standard deviation going to be 1. Therefore, in this question, D is the answer. The mean and the standard deviation have the value mu equals to 0 and sigma equals to 1. But notice that for this standard normal curve, which is called standard normal distribution, mu going to be 0. Obviously, this point here, the standard deviation, which is sigma, equals to 1. That's the answer for this question number 5. Question number 6. Draw a true normal curve that has the same mean but different standard deviation. Describe the similarity and difference. Even if you say draw a true normal curve, you are not technically drawing it. And you have to draw in your piece of paper and find the similarity and difference and answer this question after you compare the two curves. Okay, I'll draw for you. What happens is this. Okay, you're drawing two normal curve. Okay, has the same mean but different standard deviation. Okay, it looks like this. This is the data here called x value here, and this is the mean, whatever. Let's say mean is 100. Okay, for example, and that's the one curve. Let me draw properly here. That's the one. And a standard deviation for this curve, let's say standard deviation is going to be sigma equals to 10. But if you draw another standard curve with the same mean but different standard deviation, let's say draw with the red color here, looks like this. Looks like this. Okay, that's the same mean but standard deviation is going to be 5. And what happens is, as you have a larger standard deviation, which is the black curve here, that spread out more. Therefore, you can notice in this two curve where largest standard deviation is spread out more compared to smaller standard deviation with the same mean. With and to answer the question, the two curve will have the same line of symmetry. The same line of symmetry That's the one. The same here. That's the one line of symmetry. You see that? That's the same line of symmetry. The curve with the largest standard deviation, which is black one, will be more spread out than the curve with smaller standard deviation. You see that? Largest standard deviation will spread out more than a smaller standard deviation. Okay. Question number 7. The study was conducted. The results in the following frequency histogram determine whether or not the histogram indicates that normal distribution could be used as a model for the variable. Notice that this distribution is skewed right. Okay, it's skewed right. Therefore, we cannot use the normal model in this case for the variable. Therefore, the answer is going to be A. This histogram is not bell-shaped, so the normal distribution could not be used as the model for the variable. Okay. Question number 8. The graph of the normal curve is given. This is the normal curve, not the standard normal curve, because we have a data here and the mean is 530, not 0. If mean is 0, this is called standard normal curve, as you know before. And what's the value of mu? The mu is going to be corresponds to this point here. Mu is 530. What's the standard deviation? Standard deviation is difference between these 2 points, and 545 minus 530 which gives you 15. Sigma is 15. Okay, that's the answer. Question 9. Draw the normal curve with mu equals to 63 and sigma equals to 16. They already draw for you. You select the right answer. Okay, obviously the answer is B, because obviously this is as a mean 63 and sigma 16. If you add 16 and 63, you get 79. If you subtract 16 and 63, you get 47. Okay, that is called normal curve. And the inflection points is obviously 79 and 47 are inflection points. Question number 10. Consider the normal distribution defined by given figure. You see this, the distribution. Find the mean and the standard deviation of the distribution. Okay. The mean is this points. It doesn't mark what is the mean is, but notice that mean is a halfway through this through two numbers, because you see this 60% area. This points is one standard deviation above the mean. This points is one standard deviation below the mean. And since the area is 60%, you know this points in the middle, which is mean. Let me put the red dot here. The red dot represents the mean, which is the average of these two number. I should say these two are inflection points. Therefore, the mean mu going to be 2.9 plus 4.1 divided by 2, which is going to be 7 divided by 2 is 3.5. That's 3.5. Okay. Now this is 3.5. This points here. Now what's the standard deviation? That's the 4.1 minus 3.5. Sigma equals to 4.1 minus 3.5, and you get 0.6. 0.6 is the sigma, or standard deviation. Question number 11. Suppose the birth weight of full term baby are normally distributed with the mean 30 to 50 and the standard deviation 480. Complete part A through C. And first part, draw the normal curve with the parameter label. And here you have to find the right graph. There's 4 graph here, and let's find the graph with the mean 30 to 50 first, and 30 to 50. These two are here. This is the 30 to 50 here. This 30 to 50 here. Okay, but you have to find the correct graph with the correct standard deviation. Standard deviation 480, and if you add 480 on this 3250, you get 3770. Therefore, D is the right answer. Okay. Now part B, said the reason that represent the proportion of full-term baby who weighed more than 40 to 10 grams. Choose the correct answer below. And you're looking for the area which has a reason which has a shadow in more than 4,210 grams. Okay, obviously answer is this one. Okay, because see 4,210 more than, and this area here represent more than 4,210. That's the answer. But that's not, because that's not the mean, because we have mean 3250. That doesn't have it. Okay. What do you mean by this area is 0.0228? Okay, here's the question. If this area here, let me draw it here by itself. Okay, let me draw it here. If you have this graph here, let's say 40 to 50 here. Sorry, 40 to 10. Okay, let's say this area is, let's say part C says this area is 0.0228, and this is of course x line, which is random variable. Suppose read the problem. Suppose the area under the curve to the right of 4210 is 0.0228. Provide the interpretation of the results. In other words, what do you mean by area on the right of this 4,210 is this much? Okay, what do you mean by that? Okay, that means the probability. Okay, the area is always represented as a probability here, and in this case answer is A. Read the question. The probability is 0.0228 that the birth weight of the randomly chosen full-term baby in this population is more than 4,210 gram. In other words, if you look at the other way around, this is going to be 2.28%. This is the proportion. This is the percentage. This is 2.28%. That means if you choose 100 baby randomly, 2.28% of the baby has a weight more than 4,210 gram. Make sense? That's another way to interpret in terms of percentage. In terms of probability, the probability that a randomly chosen full-term baby whose weight is more than 4,210 is 0.0228. There is two interpretations. Question number 12. Suppose the length of human pregnancy are normally distributed. Again, it says normally distributed. Therefore, you have this normal curve with mu 266. The mean 266 you can see here. Standard deviation 16. Okay, and complete part A and B below. The figure on the right represents the normal curve with mu 260 days and sigma 16 days. The area on the right of 295 here is 0.0350. Okay, this area is, let me write down here, this area is 0.0350. This is the area of this region, or area to the right of this point 295 is 0.350, and this is also called proportion, and you have to give two interpretations of these results. First interpretation, one interpretation, a second interpretation, and the next one. Okay, and remember that this is the percentage, also proportion as a probability, and here first part you're writing for your answer in terms of proportion. Select the correct answer choice here. Since this is more than 2795, you choose last more than, not less than. Choose the answer A. the proportion of human pregnancy that lasts more than 295 days is 0.0350. That's the one interpretation. Second interpretation, and same thing. You just change this proportion as a probability. You read as a probability. Therefore, choose the first one here because it says last more than, because greater than 295 is more than, not less than. The probability that the randomly selected human pregnancy lasts more than 295 days is 0.0350. Okay, makes sense? And part B is similar, but you have a area between two days, 285 and 300 days. It gives you area is 0.1007. Okay, now this is the area between two numbers. Here number are days, right? For similar question, interpret this number. What do you mean by this area? This is the area, okay? Area. Interpret that. Again, you can interpret the area as a proportion, also as a percentage, and you have to choose in between because you have two numbers between 85 and 300. I'm choosing this B option here. The proportion of human pregnancy that lasts between what, 285 and 300 days is 0.1007. Okay, now for the second interpretation you do the same thing, but you use a probability to interpret this second time. Therefore, in this question also you don't choose the A, we have a B here. The probability that a randomly selected human pregnancy lasts between 285 and 300 days is 0.1007. Okay, that's the other. Question number 13. Use a normal distribution applet to complete the part A3. Question number 13. Use a normal distribution applet to complete part A through E. Below, here's the applet. You simply click the applet here, and it's show you like this. Okay, and you have the normal distribution curve, and you see the x value here, and the mean is given, standard deviation is given, but you have a slider. You can slide, you can see how this graph changes with the mean and the standard deviation. First part of the question is we use the mean slider, increase the value of mean from 0 to 4. What's the graph of the normal curve while doing this? What happens to the graph when mean increases? Let's increase the mean from 0 to 4. Mean is say mean is 0. Let me go scroll down here. Mean is 0 here. Put the mean 0. Okay, and put the 4. Slide it down to 4. What happens? What do you see? Do you guys notice what happens? Mean 0, shift right. Pretty much graph shifted to the right, correct? What happens? What happens to the graph where mean increases? Shifted right. Okay, point check. Using the mean slider, decrease the value from 4 to -4. What's the graph of normal curve while doing this? What happens to the graph as the mean decreases? Mean is 4. Let's say you decrease the mean to -4. Okay, what happens? Graph shifts to the left. Okay, shift left. What happens to the graph when mean decreases? Shift to the left. Check. What does the peak of the graph occur? Where does the peak of the graph occur? Remember that the peak of the graph occurs at the value of the mean. See whatever mean here. See, mean is what? 0. See, mean 0 here. Peak of the graph occurs at mean. If you shifted mean to 5 or 4, whatever, peak of the graph occurs at the mean. Therefore, where does the peak of the graph occurs? In the value of the mean. Part D. Place the graph at mu equals to 0. Let's mu the 0. Mu 0. But this is mu, it doesn't matter. Just let's this 0 here. Okay. Now increase the value of sigma from 1 to 3. 1 is here. Sigma, look at the sigma is 1. It's somewhere here. Okay. Somewhere here. Pretty close here, right? Somewhere. It's the 1 here. Okay. All right. 1.01, basically 1. And now increase the value of sigma from 1 to 3. 1 to 3. You slide to the right. This standard deviation. And see what happens. Look here. Mean doesn't change. See, mean doesn't change, but what? The graph more is spread out. Right? You see that? Mean doesn't change. That means center of the graph does not change, but the graph is spread out more as the standard deviation increases. Therefore, spread of the graph increases, the center of the graph is unchanged. Okay. Part E. Place the graph at mu equals to 0, and here mu equals to 0. You can see that. Use the sigma slider. Decrease the value of sigma from 3 to 0.75. Okay, let me put that to 3 here. Sigma 3. Decrease to 0.75. Okay. Now looks like graph is spread out a little more, but if you slider left to 0.75, what happens? You can notice that graph is going to be narrowed down, right? Makes sense? That means spread of the graph changes, decreases. One more time. When sigma is 3, this is the spread of the graph. Look at this line represents the spread, okay? And if you scroll to the left and bring 0.5, spread is going to be decreases. Therefore, what happens when you decrease the standard deviation? Spread of the graph decreases. Again, center of the graph does not change, unchanged. And check the answer. Now, last question, question number 14, and here is the question number 14 here. This is similar to previous one. Suppose the monthly charge of the cell phone plan are normally distributed with the mean 58 and standard deviation 17. You can notice that here, normally distributed with the mean and the standard deviation. Draw the normal curve with the parameter label. Okay, and in this question, this is the right normal curve with the parameter, because you see that 58 is the mean, and if you add 17, you get 58 plus 17, which is 75. If you subtract 17 from 58, you get 41. Therefore, pretty this is the one standard deviation above the mean, this is the one standard deviation below the mean. That's the right answer, part A. Answer is D. Choose the correct graph below. What's the second question? Set the region that represents the proportion of the plant that charge less than $41. Therefore, 41 here, but that's not the mean. Remember that. But this is not the mean. But this point is the mean. But mean is 58. Therefore, I'm choosing this answer here. 58 is the mean. 41 is one standard deviation below the mean. Therefore, this area represents the region that represent the proportion of the plan that charge less than $41. Therefore, this is the right answer, B. Part C. What's the part C? Suppose the area under the normal curve to the left of x equals $41 is 0.1587. If this tells you, hey, this area is 0.1587. Okay, and in other words, as a percentage, this is going to be 15.87%. In other words, the total area under this curve on this portion is almost 16% of total. Okay, that's what that means. And select the correct choice below to find the answer box to complete your choice. Okay, what is the interpretation of this area? That's the question. Area is probability. That means the probability that the randomly selected cell phone plan in the population is less than how much? $41 per month is 0.1587. In other words, in that particular plan, 15.87% of people pay less than $41 or equal to. Okay, I should say almost 16% pay less than $41 or equal to. That's what this interpretation is. Make sense? In another word, almost 16% people pay $41 or less as a monthly bill for that cell phone plan. Okay, that's all about this section 7.1 homework. Thank you for watching.